So, good day to each and everyone. Good day, Sir Fernandez. Hoping that everyone is having a great day. So, the Group 8 is assigned to discuss about ULOC. So, explain how climate change happens and its implications. So, the Group 8 covers the following topics. So, the first one is Earth's movement around the sun. The second one is melancholic parameters. The third one is global warming. And lastly, greenhouse gases. So, by the way, I am Venica Macy Uganap, the first reporter of Group 8, which is the topic that I will be going to discuss is about the Earth's movement around the sun. So, it is another consideration in explaining climate change, which is an interaction between the sun and planet Earth. So, is it quite interesting, right? So, sit back and relax as we go along our journey in learning about Earth's movement around the sun. So while the orbit remains an ellipse, its position or orientation in space changes over time. So the Earth's tilt position results an equal amount received of sunlight. So it's spinning around its own axis with imaginary line from North Pole to South Pole, so which dips and wobbles gradually. So while the orbit, when we say orbit, it is the curved path of a celestial body, celestial object or spacecraft around a star, planet, or moon, especially a periodic elliptical revolution. So while the orbit remains an ellipse, so actually guys, on the orbit, it is the curved path which the celestial object, or let's say the planets, nagatuyok sila dito But then, it says that remains an ellipse. Actually, ang path, it is not a perfect circle, so it is actually a regular oval shape. So its position orientation in space changes over time. So there is still position result an unequal amount received of sunlight. So why it is unequal? So while the Earth moves around the sun, actually guys, it is not straight up. The Earth is actually tilted. Pahiwi siya, move around the sun. So, di siya straight up. So, mauna siya, it causes the amount, it causes an equal amount of receive of sunlight. So, it's spinning around its own axis with imaginary line from North Pole to the South Pole, which dips and wobbles gradually. So, dili lang, while nagatuyok si Earth around the sun, nagatuyok po siya itself to its own axis. If makita ninyo sa illustration, we have this imaginary line from North Pole to South Pole. So that imaginary line is called axis. So it moved unsteadily from side to side and slowly. Okay. If you can see in the illustration, it is the location of northern hemisphere solstice relative to the perihelion. So 130 KYA or kilo years ago or 1,000 years ago, last interglacial begins, high tilt increases sunlight at the northern latitudes. Perihelion occurs in northern hemisphere, so it is called spring. So poles moves over time. So it's called precession. So what is precession? Precession of the equinoxes refers to the motion of the equinoxes relative to the precession of the Earth's axis of rotation. So it happens over thousands of years. So 127 KYA precession puts northern hemisphere, or what you call summer, at perihelion. So 124 or KYA 124 KYA or kilo years ago, perihelion is reached in the northern hemisphere, or which you call autumn. So tilt has reduced too. So perihelion, what does perihelion means? It is the point in the orbit of the Earth closest to the sun. So aphelion refers to the point in the orbit of the Earth farthest from the sun. So aphelion is opposite to perihelion. So again, if you can see in the illustration, we have this ideal circular orbit. So ideal circular orbit, so it is, if you can see kanang putol-putol tuldok, mo na siya ang ideal circular orbit kung saan nagatuyok ang planets And it's true that it is elliptical, so eccentric orbit. So eccentricity of orbit changes over time. So we all know that the Earth makes a complete revolution around the Sun once every 365 days or 1 year, following an orbit that is elliptical in shape. So this means that the distance between the Earth and Sun, which is 93 million miles on average, so it varies throughout the year. So during the first week in January, so the Earth is about 1.6 million miles closer to the Sun. So when we say closer to the Sun, this is referred to as the perihelion. So the aphelion, or the point at which the Earth is about 1.6 million miles farther away from the Sun, occurs during the first week in July. So this fact may sound counter to what we know about seasons. So in the northern hemisphere, but actually the difference is not significant in terms of climate change. So, and it is not the reason why we have seasons. So what is the reason actually? So seasons are caused by the fact that the Earth is tilted on its axis by 23.5 degrees. So again, while the Earth is moving around the Sun, it is not straight up. Actually, it is tilted. Pahiwi siya, nagatuyok around the Sun. So the tilt's orientation with respect to space does not again, the Earth moves around the Sun is not straight up, so it is tilted. So if you can see in the illustration, we have this for seasons. So September 22 to 23, it is autumnal equinox. June 20 to 22, summer or solstice. March 20 to 21, vernal equinox. And December 21 to 22 is winter solstice. Okay, to the next slide. It's all about equinox and solstice. So it's quite long, so later on I'm going to give you the PPT so that you will review more about equinox and the solstice. So actually it's have a important role also in Earth's movement around the Sun. So I'll give you the PPT later on so that you will review or you will learn about this. In addition, this is the elements in this interaction between the Sun and the Earth are defined as follows. So the first one is aphelion, refers to the point in the orbit of the Earth farthest from the Sun. And the second one is perihelion, is the point in the orbit of the Earth closest to the Sun. So when we say Earth's axial tilt is the inclination angle of the Earth's rotational axis in relation to a line perpendicular to its orbital plane. So precession is the change of the orientation of the rotational axis of the Earth. And equinox refers to the time the Sun and at noon is directly over the equator. So it happens twice a year and causes an almost length of day and night. So solstice happens when the Sun at noon sits above the Tropic of Cancer or Tropic of Capricorn. So the summer solstice has the longest period of daylight in the year, and the winter solstice has the shortest period. So again, precession of the equinoxes refers to the motion of the equinoxes relative to the precession of the Earth's axis of rotation. So it happens over thousands of years. So later on, we will discuss further about this in the Milankovic parameters. So before I will end my discussion, I will give some recap about the Earth's rotation and revolution, or let me explain my topic today in simpler way about Earth's movement around the Sun. So it's about Earth's rotation and revolution. I know you've tackled this topic when you are in elementary or in high school, or even now, even when you are in senior high school. So Earth's rotation and revolution. So you've seen the sunset. right? So, and if you get up early enough, maybe you've seen it rise too. So, but have you ever wondered if the sun rises every day and sets every night? So, that's the question. So, we have this misconception, no? Even kita tong bata kata nga, ang sun, ang moon, ang dagalihok. Kay buntag na si sun na, siya na amuap. Kay gabi na si moon na amuap. So, that is our misconception before. So, where does it go when we can't see it? Okay, that's the question. Well, nowhere. It's actually us that goes somewhere because we're on the earth and our planet is always turning or spinning on its axis. So imagine a line passing through the center of the earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. So earth spins around on this axis like a top. So if makita ninyo the illustration kaganina, we have this imaginary line. So it is called axis from the North Pole to South Pole. So that is the imaginary line called axis. So when we say this is spinning movement is called the Earth's rotation. And the Earth's rotation is what gives us day and night every day. So when we say rotation, it is when a planet or moon turns the way around or spin on its axis one time. So if you're on the side of the Earth that facing from the sun as the Earth is spinning, so it's night. If you're on the side of facing the sun, it's day. So now hold on tight because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. So this movement is called its revolution. Okay, revolution, when a planet or moon travels around the body it is orbiting one time. So revolution is equal to 1 year or 365 days. So one full orbit all the way around the sun is one revolution. And the Earth takes 365 days or 1 year to complete a revolution. So have you got all this far? So the Earth is rotating on its axis, creating day and night. At the same time, it's revolving all the way around the sun. So gets in you guys. So as the Earth daw revolving around the sun, nag-revolve po siya and nag-tuyok po siya on its own axis. Okay, for example, mo ni ang sun. Mo ni siya ang sun, so mo ni ang Earth. So while nagatuyok ang Earth, naga-move ang Earth around the sun, naga-move po siya on its axis, creating day and night. So nagatuyok si Earth itself on its axis, it creates day and night. It is 24 hours. So while nagatuyok siya itself, creating day and night, nagatuyok po siya around the sun. So it's called revolution. So every tuyok ni Earth around the sun, which you call revolution, it takes 1 year or 365 days. So here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted just a little. So again, while moves the Earth around the sun, it is not straight up. It is actually tilted. Pahiwi siya nga nagtuyok sa sun. So it's not all that much. So just a little lang, tilted siya. But this tilt causes one part of the Earth to lean towards the sun, while another part of it's leaning away. So this means that part of our planet's surface gets different amounts of sunlight and heat. So why am I telling you this? Well, as the Earth travels around the sun, it creates a pattern through the year. So what is pattern? Pattern is a set of objects or events that are repeated regularly. So the Earth travels around the sun, it creates a pattern through the year. So these patterns happens over and over again, and I'm sure you notice it. So at certain times of the year, you see the northern hemisphere leans toward the sun and the southern hemisphere leans away. And at the other times, the southern hemisphere leans toward the sun and the northern hemisphere leans away. So that pattern, everyone, what makes seasons. So that it's that when the part of the world that you're living in is leaning toward the sun, it is warm. So, and the days are long, it is summer. When you're on the parts that living away from the sun, it's cold. And the days are short, winter. So, in between, it's spring or autumn. So, if the earth were tilted, we would have the same season all year long. So, that's the explanation why we have this called seasons. We have these patterns. So, what does all this show us? So, the conclusion is, it showed that what looks to us to be the motion of the sun in the sky is really caused by the motion of the earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. So, hawaon na nato ng misconception na si sun o si moon ang nagalihok. Nagalihok, for example, buntag, si sun na ang morise, ang musaka, gabi na, si moon na, sila ang nagalihok. But actually, it's the earth. It caused by the motion of the earth. So that sun is always going to be the center of attention. So that's it. I hope you learned a lot from my topic. It's about the Earth's movement around the sun. So let's proceed to the next topic, which is all about Milankovic parameter.
Hey everyone, my name is Janela Zapanta. Continue the discussion on Milankovitch. I will discuss to all of you the Milankovitch cycle. This includes the eccentricity, obliquity, and the Earth axis of rotation in point known as position. First, the shape of Earth orbit known as eccentricity. It isn't perfectly circular, but it's pretty close due to the pull of gravity from Saturn and Jupiter. The Earth's annual pilgrimage around the Sun is not perfectly circular, but it's pretty close. Over the time, dahil sa pull of gravity from our solar system, the two largest gas giant planets, Jupiter and Saturn, causes the shape of Earth orbit to vary the nearly circular to slightly elliptical, as you can see from the demonstration. The eccentricity measure is how much the shape of Earth orbit departs from a perfect circle. This variation affects the distance between Earth and the Sun. Eccentricity is one of the reasons why our seasons are slightly different lengths, which the summer in the northern hemisphere is currently about 4 to 5 days longer than winters, and the spring about 3 days longer than the fall times. Kung gamay ang eccentricity, the length of our seasons gradually evens out. The total change in global annual insolation due to the eccentricity cycle is very small. Because the variation in Earth eccentricity are fairly small, there are relatively minor factors in annual seasonal climate variation that affect the climate change. The next one is the angle Earth axis is tilted with respect to Earth orbital plane known as obliquity. As you can see in the demonstration, the angle Earth's axis rotation is tilted as it travels around the sun between 22.1 and 24.5 degrees perpendicular to the Earth orbital plane. The greater Earth axial tilt angle, the more extreme our seasons are, as each hemisphere receives more solar radiation during its summers, when the hemisphere is tilted towards the sun, and less during winter. When it's tilted away, the larger tilt angle favors period in the glaciation. It is melting, the retreat, the glacier, and the ice sheets. These effects aren't uniform globally. As you can see, the more tilt angle the weather may have the differences. The next one is the direction of Earth axis of rotation is pointed known as position. It swivels slightly upon its axis. As you can see in the demonstration, As Earth rotates, it swivels slightly upon its axis, like a slightly off-center spinning toy top. This swivel is due to the tidal forces caused by the gravitational influence of the Sun and the Moon causes Earth to bulge at the equator. It is affecting the rotation and trend in the direction it this swivel relative to the fixed position of the stars is known as an axial position. The small changes set in motion by Milankovitch cycles each operate separately and together to influence Earth climate over a very long time span, leading to larger changes in our climate over tens of thousands to hundreds of thousands of years. The Milankovitch parameter seems to be part of the cause of climate change, though not only cause, but there are some other factors needed. Scientist Milankovitch, who studied climate change, agreed that the average temperature of the planet has been increasing by over 90% in the latter part of 21st century. Milankovitch combined the cycle to create a comprehensive mathematical model for calculating differences in solar radiation at various Earth latitudes along with the corresponding surface temperature. In addition, it was his belief that obligity was the most important of the three cycles for climate because it affects the amount of insolation in Earth's northern high latitude region during summer.
Good morning to each and everyone. I am Natalie Sam Ozuniga, the next presenter for today's discussion. But before anything else, and before we start discussing, I will dic- I will dictate to you our learning objectives for today's discussion. First, that is to identify and to define what is global warming. Moreover, what are the causes and the effects of global warming? And lastly, to consider some of the things that may stop and reduce global warming. But before anything else, I would like to remind each and everyone that at the very last page of this PowerPoint presentation, on your respective screens, I will present to you the links that I have collected and read about all about global warming. And other than that, I would like to apologize for the unnecessary noises that you can hear because I don't have any control about the noises that surrounds me. Let me begin. Let us define global warming. As we all know, global warming is the long-term heating of Earth's climate system observed since the pre-industrial period between 1850 and 1900s due to human activities, specifically fossil fuel burning, which increases heat trapping greenhouse gas levels in Earth's atmosphere. The term is frequently used and interchangeably with the term climate change, though the latter refers to both human and naturally produced warming and the effects it has on our planet. It is most commonly measured as the average increase in Earth's global surface temperature. As defined in our SIM, global warming is a phenomenon of climate change characterized by a generally increase in average temperature on Earth, which modifies weather balances and ecosystem for a long time linked to the increase of greenhouse gases, particularly the carbon dioxide. This is greatly abated by the actions of human beings, either from the past and present actions. Now, at this juncture, I would like to present to you data or a graph that presents the global temperature and carbon dioxide. The x-axis or the x-axis shows the year, and the y-axis shows the amount of carbon dioxide or the CO2 in the atmosphere measured in parts per million. It shows that the carbon dioxide increases almost at the same period. It shows directly proportional conditions and temperature increases as carbon dioxide also increases. As you can see on our PowerPoint presentation, the blue markings on the graph or the global temperature as it increases, the carbon dioxide also increases. Now, in this graph, cited from NASA's Goddard Institute for Space Studies, this graph illustrates the change in global surface temperature relative in 1951 to 1980 average temperatures, with the year 2020 tying with 2016 for warmest on record. As you can see, in 1880, the temperature of the globe was not as high as today's temperature. As year passes by, it went up and down consistently, and at 2016, it peaked to the to its warmest record, and it decreased in 2017 to 2018, and increased once again in 2020, tying to the 2016 record. So basically, what is really global warming in a more simpler terms or meaning? Okay, global warming is the term used to describe the rising of the average temperature on Earth. It has to do with the overall climate of the Earth rather than the weather on any given day. Lastly, these are the things that may stop or reduce global warming. First is to invest in energy efficient appliances. When shopping for refrigerators or washing machines and other appliances, we must look for the Energy Star label. It will tell you which are the most efficient. Second, to reduce water waste. Saving water reduces carbon pollution too. That's because it takes a lot of energy to pump, heat, and treat your water. So take shorter showers, turn off the tap while brushing your teeth, and switch to water sense labeled fixtures and appliances. About 100 million kilowatt per hour of electricity per year would be saved, avoiding 80,000 tons of global warming pollution. So can you imagine that massive amount of digits you can save from this carbon pollution? That's how you can reduce global warming. Third, we have actually eat the food you buy and make less of it meat. Since livestock products are among the most resource intensive to produce, eating meat free meals can make a big difference too. So it's basically telling you to eat a more healthier foods rather than processed foods. You did not just help reduce global warming, but you also help your well being through exercising, through executing, eating foods that are healthier. Fourth, we have buy better bulbs. LED light bulbs use up to 80% less energy than conventional incandescent bulbs. They're also cheaper in the long run. A 10-watt LED that replaces your traditional 60-watt bulb will save you how many pesos over the light bulb's life. Lastly, the pull the plugs. Taken all together, the outlets in your home are likely powering about 65 different devices. So we must not live fully charged devices plugged into our home's outlets. Unplug rarely used devices or plug them into power strips and timers. And adjust your computers and monitors to automatically power down to the lowest power mode when not in use. So the last or the fifth one, we could all relate to this because maybe or after using or when we go to sleep after using our cell phones, we just plug it on our chargers and just leave it overnight. So We must practice we must practice these practices for us to be able to reduce and stop global warming. Once again, most of the informations and the datas that I have presented to all of you were not really found on our sim. You may visit these links so that you may want to further understand the graphs and the data that I have presented. You may take a screenshot and later on visit it. Once again, I am Nathalie Sam Ozuniga, your presenter for the discussion of global warming, and I hope you got something. Thank you.
Hello everyone, I am Herlene J. Astrowalan, and for today's discussion, I will discuss to you the greenhouse gases, the main greenhouse gases, and John Tyndall. So before we discuss the greenhouse gases, I will first give a bit of explanation on what is greenhouse effect. So let us take this picture for an example. This is the sun, and this is the earth, and also the earth's atmosphere. So the greenhouse effect is a natural process that warms the earth's surface. So when the sun's energy reaches the earth's atmosphere, some of it is reflected back to space, and some of it is being absorbed and radiated by greenhouse gases. So greenhouse gases, they prevent heat from escaping into space, which resulted to warming the planet. So what is greenhouse gases? So as I said before, these gases traps the heat of the sun. They naturally captures and holds the heat from the sun in the atmosphere so that the earth's temperature becomes hotter. This mechanism is really good on our biosphere because without these greenhouse gases, our earth's atmosphere would become like of Mars or Antarctica, which is extremely cold. The main greenhouse gases, and these are water vapor, carbon dioxide, methane, ozone, nitrous oxide, and chlorofluorocarbons. So I will give a little bit of explanation to the main greenhouse gases. So first we have water vapor. So water vapor is water in a gaseous instead of liquid form. It can be formed either through a process of evaporation or sublimation. So water vapor in the atmosphere serves as the raw material for cloud and rain formation. Next is carbon dioxide. So carbon dioxide is a colorless, odorless gas found in our atmosphere that has a formula of CO2. And the one example of carbon dioxide is vehicles because the gas that the vehicles produce is carbon dioxide or CO2. But vehicles also produce the greenhouse gases nitrous oxide and methane. Next is methane. So natural gas or methane is lighter than air and will typically disperse in event of a leak. So one example of methane is LPG. So there are a lot uses of methane, but using it for cooking is a very common situation. Methane po is a hydrocarbon and it's lighter than air. Therefore, it produces more energy per unit weight in comparison to oil and coal. It is also preferred for cooking since it does not smell and does not leave soot on the cooking utensils. Next is ozone. Ozone occurs naturally at a higher elevation in the atmosphere where it forms a layer that blocks UV light, which is harmful to plant and animal life from reaching the Earth's surface. So, however, there are so many human-made chemicals that break down ozone in the stratosphere and create holes on the ozone layer. Next is nitrous oxide, or more commonly known as laughing gas, is a potent greenhouse gas that is 300 times more powerful than carbon dioxide. It was called a laughing gas because it can create a feeling of euphoria, which may make you laugh easier, but its primarily effect is to relax you and leave you calm and less aware of any fear or anxiety you may feel during dental procedures. Next is chlorofluorocarbons or CFCs, are compounds that only contains carbon, chlorine, and fluorine. They are exceptionally strong greenhouse gases and are also responsible for the destruction of stratospheric zone. While acting to destroy ozone, CFCs can also trap heat in the lower atmosphere, causing the Earth to warm and climate and cause weather to change. Next is John Tyndall. John Tyndall is born on August 2, 1820 and died on December 4, 1893. He is an Irish physicist who, during his long residence in England, was an avid promoter of science in the Victorian era. He is well known for his work on the absorption of heat by gases such as water vapor and carbon dioxide in the atmosphere. So John Tyndall is concerned onto what would become of the Earth's atmosphere if industrialization becomes widespread. John Tyndall thinks that if ang industrialization nato kay mas maglawak, ang Earth's atmosphere kay pwede ma-damage. So in Tyndall's time, ang pag-burn of fossil fuels kay dili excessive or not good enough para ma-damage ang Earth's atmosphere. And as you think it in the future, na mga possibilities na mas mag-increase ang pag-burn o fossil fuel like coal kay tungod, kay-increase naman ang atoang industrialization, which is true. And that's all for my report. Thank you for listening.
Good day everyone, I am Arij Samporna. So this is the continuation of greenhouse gases. So my topic for today is all about Charles David Killing and his graph that he called the Killing curve. So Charles David Killing is an American scientist. So he discovered the carbon dioxide and he is the first scientist to develop an accurate technique for measuring in the air concentrations of carbon dioxide. So Charles David, whose recording of carbon dioxide at the Mauna Loa in Hawaii Observatory confirmed Svante Arrhenius's proposition of possibility of anthropogenic contribution to the greenhouse effect and the global warming by documenting the steadily rising carbon dioxide levels. So according to where 2003 in mid of 20th century lead to find out if increase of burning fossil fuel and the consequent release of carbon dioxide in the atmosphere and changing the global temperature. He started to measure the amount of carbon dioxide in the atmosphere far away from the industrialized nations but on the extinct volcano on the island of Hawaii in the Pacific Ocean. So this graph known as the Killing curve plots average amounts of carbon dioxide in the atmosphere taken from a monitoring station at the Mauna Loa Observatory in Hawaii. So David Charles began to measuring carbon dioxide levels at the Mauna Loa Observatory in 1958. The concentration of carbon dioxide in the atmosphere is measured in parts per million or ppm. A concentration of 320 ppm means that out of every 1 million molecules in the atmosphere, 320 are carbon dioxide. The black line represents monthly averages of carbon dioxide concentrations. This shows a seasonal cycle where there is less carbon dioxide in the atmosphere during the northern hemisphere spring and summer months, when more plants are growing and taking in more carbon dioxide. There are fewer plants undergoing photosynthesis during the northern hemisphere winter months. So there is more carbon dioxide in the atmosphere. So, Killing curve graph shows the seasonal and annual changes in atmospheric carbon dioxide. So first, the graph shows that the concerns of Engineer Tyndall in 19th century and Dr. Killing in the mid of 20th century were well-founded. The carbon dioxide concentration has gone up and the temperature has also risen as a proof of global warming. Second, scientists turn to history and technology to substantiate that there is a causal relationship between high carbon dioxide and temperature levels. These issues concerns many nations since not burning fossil fuels may mean not industrializing or modernizing after contemporary debate were laid. The debate was hinged on what really is happening and causing the global warming. Another concern area of the debate is centered on the predictions to what will happen to the climate of the world in the future. So the killing curve is a graph that shows the ongoing change in the concentration of carbon dioxide in the Earth's atmosphere. The killing curve also is one of the most compelling pieces of scientific evidence that shows that carbon dioxide is accumulating in our atmosphere. So, carbon dioxide also is a greenhouse gas. Greenhouse gases trap heat in the atmosphere and it helps keep the planet warm. More greenhouse gas molecules in the air means more heat is trapped, leading to an overall warming of the planet. So, there are two possible future actions. A. According to Sparks and Hawksworth 2004, using computer models, so the challenge is to assemble sufficient and well-established data from all over the world to make the predictions as accurate as possible. B. Scientists sitting at tipping points specifying values of meteorological parameters in which irreversible changes will take place. Upon reaching the tipping point, a new state would replace the old one. A balanced plan must be created if we want to industrialize and at the same time protecting the environment. Science has given the humanity a tool for modernization. It allows the emergence of technology that spreads and applies knowledge for the attainment of the good life.